What if I told you that right now, as you're watching this video, millions of invisible particles are striking your body, traveling near the speed of light, born from exploding stars and violent galaxies billions of light years away? These are cosmic rays, messengers from the most extreme environments in the universe. And they hold the secrets of how matter, energy, and the laws of physics behave at their absolute limits. Welcome to the Learning Studio, and in today's episode from our physics playlist, we're diving deep into high-energy astrophysics and cosmic rays, where the most energetic particles in existence tell us stories about supernovae, black holes, and the edge of space itself. You can explore the entire physics playlist by clicking the link in the description below. This topic belongs to our section Space, Time, and Advanced Technologies, where we explore how modern physics, data science, and AI are pushing our understanding of the cosmos to unprecedented levels. The universe's powerhouses, where energy has no limits. High-energy astrophysics deals with the most violent and energetic processes in the universe, explosions, jets, and collisions so powerful that they release more energy in seconds than our sun will emit in its entire lifetime. These events include supernova explosions, when massive stars die in spectacular bursts of light and matter. Neutron stars and pulsars, dense stellar remnants that spin hundreds of times per second, emitting intense magnetic fields. Black holes, cosmic engines that tear apart matter and release jets traveling almost at the speed of light. Active galactic nuclei, AGN, supermassive black holes at the centers of galaxies, radiating more energy than all the stars around them combined. From these cosmic forges, high-energy particles, mainly protons and atomic nuclei, are accelerated to incredible speeds, forming what we call cosmic rays. Cosmic rays, the universe's subatomic travelers. Cosmic rays are tiny yet astonishingly powerful. They constantly bombard Earth, passing through our atmosphere, through our technology, and even through you, every second. But their origin story is one of cosmic mystery. For over a century, scientists have been trying to answer questions like: where do the highest energy cosmic rays come from? How are they accelerated to energies billions of times greater than anything we can produce on Earth? And what do they tell us about the extreme physics of the universe? When these cosmic rays hit Earth's atmosphere, they collide with air molecules, creating cascades of secondary particles, a shower of energy that detectors on the ground can measure. Studying these events allows scientists to reverse engineer the physics that created them, like listening to an echo and reconstructing the sound that caused it. AI and machine learning, unraveling the cosmic code. Modern cosmic ray research is incredibly data-intensive. Observatories like the Pierre Auger Observatory in Argentina and IceCube in Antarctica collect petabytes of data from cosmic particle showers, neutrinos, and gamma rays. But distinguishing a rare cosmic event from noise is like finding a single photon in a sea of sunlight, and this is where AI becomes indispensable. Machine learning algorithms are now trained to detect and classify cosmic ray events, identify patterns in data that human eyes can't see, reconstruct trajectories of particles to trace their sources across the sky, and predict high-energy events based on historical and simulated data. In short, AI has become the universe's new detective, uncovering signals buried in noise, and transforming random data into cosmic insight. AI doesn't just help astrophysicists analyze data, it helps them understand it, bridging the gap between raw cosmic information and deep physical meaning. Gamma rays, neutrinos, and the multi-messenger universe. High-energy astrophysics is also where all the messengers of the cosmos converge. Alongside cosmic rays, we study gamma rays, the most energetic form of light, and neutrinos, ghost-like particles that pass through entire planets undisturbed. Together, they form the foundation of multi-messenger astronomy, where multiple signals combine to paint a more complete picture of the universe. For example, gamma-ray bursts reveal cataclysmic events like collapsing stars or neutron star mergers. Neutrinos help us peek inside supernovae and other hidden processes invisible to ordinary light. And cosmic rays tell us about the acceleration and composition of matter in interstellar space. Each messenger gives us a new way to look at the same cosmic event, like hearing the same song played on different instruments. The future, from space telescopes to AI observatories. The next decade of high-energy astrophysics will be revolutionary. AI-driven observatories like CTA, Cherenkov Telescope Array, and next-generation detectors on the Moon and in space will allow us to map cosmic ray origins with unprecedented precision. Quantum sensors and deep learning algorithms will merge, enabling near-real-time cosmic event detection. And one day, we might even build AI systems capable of autonomously discovering new physical phenomena, not just analyzing the data, but understanding it. When that happens, it won't just be humans studying the cosmos, it will be intelligent systems learning from the universe itself. Why it matters. High-energy astrophysics teaches us that the universe isn't quiet or static, it's a dynamic, explosive, and creative system that constantly recycles energy and matter. Cosmic rays and gamma radiation are not just astrophysical curiosities, they're the universe's most powerful teachers, revealing the limits of known physics and pointing toward what lies beyond. Through AI, we're learning to interpret the universe's most energetic language, a language written in particles, light, and gravity. This is the Learning Studio, and this was our episode on high-energy astrophysics and cosmic rays. If you loved exploring the universe's wildest energies and hidden messengers, make sure to like, subscribe, and check out our physics playlist linked below. In our next episode, we'll venture into cosmological simulations and the digital universe, where scientists use AI to recreate cosmic evolution from the Big Bang to today. Because in physics, every cosmic ray that hits us is a reminder that the universe is alive, learning, and endlessly curious.